Right. Cool. Okay. Good morning, everyone. Thanks for attending this webinar. My name is Chris Brunskill. I am head of the Small Satellites and Future Constellations domain and working on the in-orbit demonstration program here at the Catapult. Off camera, we also have Graham Taylor, who's part of my team and also working on IOD. He'll be fielding any questions that come through as part of this webinar. So you should have the option to submit those on the web page. Please do pass those through at any point throughout today or this morning's presentation, and we'll either address them in line if it makes sense, or pick up any others at the end of the session as well. We had a look at some of the sign-ups that came through in the last week or two, and we sort of see a mixture of new and old faces. If you've heard anything about the in-orbit demonstration program prior to this, there's probably not going to be an awful lot of new stuff, but it's probably worthwhile sticking through just to get the sort of the message we're trying to come through with. If you're here through the contact we've had with Sensor City, this is an opportunity for us to engage with a new audience, and really the purpose of today is to plant some seeds of thought with respect to the workshop that's coming up in September up in Liverpool. We want you to be really open-minded here about the opportunities that space and particularly new small satellite-focused missions can provide. We'll go into more detail around the technology side, but the small satellites and responsive space approach really provide new opportunities, both upstream and downstream. And again, we'll expand on that a bit more in due course. So without further ado, we're going to talk today about what the IOD program is, and what it sets out to do and what it is aiming to achieve. We're going to look in a little bit of detail at the content that we expect from a typical IOD application, and then at the end we'll just briefly cover the opportunity to work with us in more depth in Liverpool as part of the Sensor City workshop. So I've deliberately made these slides quite wordy. We'll share them afterwards so you can digest them. But if you sort of let me work through them in words and you can read later. The IOD is an opportunity to take advantage of markets opened by the space sector. So what that means is we see opportunities across all industrial sectors to use space-driven services in a commercial sense. So that could be anything from transportation to the maritime industry to agriculture and so forth. Ultimately, all that a satellite platform or a satellite mission provides you with is a platform for providing data services. So if there's an opportunity to provide a new data service, if there is a data service that's currently used in those kinds of industries that might be exploited in a new way, then that's where we're really interested in looking at how the IOD program can help demonstrate those in real terms. So that's the key objective here, is to have a sort of a true-to-life proof of concept service enabled by the in-orbit demonstration program. A good example of this would be something like AIS, which is the automated identification of shipping service. This was a VHF-based system originally developed for ships to identify themselves when coming into port. It turned out that you can detect those signals from space, and now there is an extensive market in AIS services which track ships at all points during their traversal across the oceans, whereas previously, as soon as they were out of line of sight of the ports, then they would go off the grid. So that's a great example of where a simple satellite mission can provide a service into a sector that typically would have nothing to do with the space industry. We typically split this into, or the opportunities into two elements, what we call upstream and downstream. And within our bubble, what that means is the technology that goes into space, the hardware that flies, whether that's a payload or a sensor, or indeed the platform itself, so the spacecraft bus, the computers and radios and power systems that drive that payload. And we often talk about enabling technologies as well. So that could be a new type of sensor, a new type of detector, a new type of radio, a new algorithm, something that allows us to do something new that we couldn't do previously. Just a quick side point on that, the focus of IOD, while it allows us to fly new technologies, doesn't mandate that. And indeed, if there is flight proven technology that can enable new downstream services and the novelty comes in the terrestrial application, then that's something we'd be very interested in as well. Speaking of downstream, that's what we call our services element. This is the data or the user service that's provided on the ground. It could be images from a remote sensing imager, or it could be a radio service, IoT being an obvious hot topic at the moment. And then the applications that hang off those capabilities provided from orbit. So where do we fit in amongst all of this? Our role is to facilitate the flight of technologies and to enable the new satellite services. And the real focus here is on the commercial opportunities. So there's not an enormous scope for pure science or indeed for pure technology demonstration. What we're looking for are the mission opportunities that have real commercial applications where a specific customer or end user would be involved, ideally as part of the mission, the demonstration mission, to prove that concept. That doesn't preclude the option for having new or novel technologies, as I said, in terms of the upstream element involved in that, but that would be a secondary part of the mission. The primary part is to show that the commercial opportunity is practical and can work in a real context. So I'm not going to delve too much into the sort of satellites and the space element, but for those that are somewhat read in this area, we procured a series of 3U CubeSats. So these are very small spacecraft, approximately 30 by 10 by 10 centimeters. We have 4 of those ready to be constructed as we speak. And the payload space within that is roughly 10 centimeters cubed, and nominally with a mass of about one kilo. So this is what we would call 1 unit of payload space, and it's analogous to a kilo of water. So you've got 10 centimeter cube, you've got a kilo of, or a liter of water, a kilo of mass, and that's where we've got to fit in any enabling technologies on the flight part. Again, we'll go into that in more depth in terms of how that all fits together in due course. And our primary goal is to identify the enabling technology, the business cases and the market opportunities. We do some work as part of our day-to-day internally here at the Catapult to get the broad sort of scope of what those fields are. But in terms of the specifics, the specific customers, the specific opportunities, that's where we're reaching out to the community to come to us with their ideas. And our role will be to bring those together, whether that's a single applicant with a great idea that could take advantage of the platform, or to help build consortia that will take advantage of the various steps along the way. So just to break down the opportunities in a little bit more depth, this is sort of looking at it from a quite high level, but what you should keep in mind when thinking about how you can take advantage of IOD is how it differentiates from using existing satellite services. So obviously there's a lot of infrastructure in place on orbit as it stands. They provide great services in telecommunications, remote sensing and so forth, but there are obvious constraints that come with those, particularly if you aren't the owner of the spacecraft itself. If you want to buy an image from an imaging satellite provider, the practice of doing that is quite challenging. There's a lot of paperwork. It's a long and drawn out process. You often don't get precisely what you need. You have to wait for the tasking to go through the standard process. You don't get much flexibility. So the IOD program allows you to break down a lot of those barriers. The sort of main areas that we see as being benefits, and we're open to suggestions for where others may come from as well. But you can demonstrate how the satellite drives your business. And what that means is you can integrate a satellite platform as part of your business operations. Typically, this is seen as something quite scary and quite a blocker to a lot of people, organisations that don't typically work in the space sector. What we want to try and address is the fact that it's no different to having any other large piece or moderate piece of infrastructure in your as part of your sort of capital assets, whether that's a piece of manufacturing machinery, a company car, your offices. It's just another asset, and the barriers to operating and owning that within your organisation are nowhere near as high as they were in decades gone by. And really, that's the key focus that we're trying to drive upon here. There's also an opportunity of reducing the cost of access to your data. You can cut out the middleman, as it were, and have access to the data at the source. You can define exactly what the parameters of those data are, how it's presented, how it's processed, and how often it's provided within the constraints of your mission concept, that is. But that really breaks down a lot of the commercial constraints of getting access to data. Even to some extent, the free data you might see from programs such as Copernicus, which have made great steps towards enabling that to be less arduous, but you're still at the whim of the tasking provided by the operators, the owners. If you own the satellite yourself, you can provide that yourself, and indeed that leads on to the third point. You have complete flexibility of what's tasked, or what the satellite's tasked to do and when. And that really is a great opportunity that changes dependence on a third-party provider. So to give you again sort of a top-level view of the kind of constraints and opportunities that a CubeSat in particular can offer, we see a lot of really good ideas around telecoms and remote sensing. Under telecoms, we include things like M2M, so machine-to-machine communications for ISL, which is inter-satellite links. There's a challenge in that concept in that we have to show that there's a commercial service opportunity within that, but we're seeing some really interesting ideas around how that might be enabled. IoT is a really obvious one, and there's a lot of interest in the space sector in general around IoT at the moment. But we're seeing some interesting technologies around detecting IoT devices directly from orbit. But that doesn't necessarily have to be the only concept. The use of relays and gateways and so on are also perfectly viable and valid. But it's an obvious opportunity, particularly in remote areas or over wide areas of monitoring. And as I've already touched on, AIS for ship monitoring and the counterpart in aviation, ADS-B, are also obvious candidates there. I should also point out that these aren't particularly new or novel technologies or capabilities, which leads back into the technology itself not necessarily being the focus here. But if you have a really interesting commercial opportunity, a new market or a new set of customers that are unique to your organisation, that's something we'd be really interested in exploring further. Equally, if you've got a new algorithm that allows something like IIS or IoT applications or services to be delivered in greater efficiency or over greater ranges, whatever, that's also something that would be very interesting. Looking at remote sensing, space weather is an interesting one as long as there is a commercial opportunity there. If you can get satellite operators on board or satellite owners on board as part of a space weather service, then we'd be very interested in looking at that. Atmospheric composition for environmental and weather or meteorological purposes. Land use mapping is an obvious one, and ocean environment monitoring as well. The challenge there is really around what you can fit into the payload space that we have available. This is a key constraint, and that leads us on into the constraints. The data throughput is limited by an S-band downlink. Uplink is UHF only. The power is constrained in relative terms. Normally, Graham, it's 2 watts.
2 watts
average per orbit. Yeah, higher peak, but that's the kind of order of magnitude. If you need 100 watts of your payload permanently, then you're in trouble. And very specifically, if you're looking at an imaging application, the aperture diameter is a very challenging physical constraint that is hard to work around. We're not completely adverse to mechanical or physical changes to the platform itself, but that was part of a further negotiation, particularly if you really needed a larger platform, 6 or 12U, not out of the question, but fall somewhat outside of the scope of what we're looking for. The last point is the orbit in particular and the mission constraints in general. We have a single platform available for each applicant as a nominal baseline. It doesn't preclude multiple platforms, but we need a really good case to use those. The launch provider we're using is deploying from the ISS, the International Space Station. So the inclination that we're providing is only up to about 52 degrees latitude. So if you're looking at a sort of a polar applications type concept, that isn't really within the scope of the IOD program as such. Not to say we'd be interested in talking to you in general, but a little bit outside of what we can deliver through this. And long duration missions are also challenging due to the low altitude at which the ISS deploys CubeSats. 6 months is our nominal mission duration. 12 months is probably about the realistic lifetime on average you would expect for the orbital lifetime before the spacecraft re-enters and burns up. So that's the kind of order of magnitude that we're looking at. This slide is lifted from the ESA ARTIS website. I'd encourage you to go to the link at the bottom. Again, we'll circulate the slides, but just as a summary to give you some ideas of the application side rather than the sort of space segment element of it. Here are some areas that have been identified by ESA that would be very interesting for new applications and services. Waste management is an interesting one. Response to migration, a challenging application, but monitoring of human movement and evidence of human trafficking is a really challenging problem for global scope at the moment. ADS-B again is another hot topic in terms of aircraft monitoring. Alpine region services has been identified as a specific area of opportunity, particularly around transport, tourism, energy and environmental monitoring. Critical infrastructure is a really interesting one because that's becoming more and more relevant as we explore this further. Monitoring and sort of change detection, if you will, is a sort of key area that we see being integrated into new satellite services. That leads back into things like IoT and covers all of the sort of critical infrastructure services you might expect: water, food, energy, telecommunications, environmental as well. Health and well-being is an interesting one. The remote sort of locations is a sort of an obvious application there, but we also have experience of looking at where communications infrastructure, even in sort of the UK as an example, isn't necessarily robust, where things like mobile phone infrastructure or coverage is quite weak. This is somewhere where a satellite communication service might come in and fill in the gaps. And more broadly around SATCOM, security, transport, consumer applications such as augmented reality, emergency coordination, emergency services, that is, capacity building in terms of community development, e-learning, e-government, energy and media. Sort of a wide area, but those are the wide range, but those are the specific areas identified. So they don't have to align with those in terms of the mission concepts for our IOD program, but that gives you an idea where some thought has been put into the kind of applications that are quite timely at the moment. Right. Okay. So the IOD program, as a program, is broken down, as we see it, into sort of 4 key areas, and we would expect to see these 4 roles to be specifically identified in any application into our program. This could be one single applicant, it could be multiple applicants, it could be 4 individual applicants. The way we break it down is the payload developer. So we would expect to see some kind of flight hardware to be integrated into the platform, and we are here to help that provider work with Clyde Space, who are providing the platforms as part of the integration. That could be a subcontracted element, it could be a university, it could be a key piece of the R&D. The operator itself, so this is the organization that will ultimately provide the operation services for the spacecraft itself. So tasking of any data acquisition, platform monitoring, housekeeping monitoring, health monitoring, as in the platform health, and mission operations and planning. The service provider, we differentiate from that. So these are the organizations or the people that will take advantage of the capability, that will exploit the service and engage with the end users, and indeed the end users themselves. So a very good application, we would expect to see all four of those criteria or those categories identified with roles allocated to them or defined around them. And really what we want to see in terms of the end user case is a specific organization or entity that's been identified that could make use of it, at the very least through a strong letter of intent or ideally as a partner within the application. To break that down a little bit more, payload developers, we look at this in terms of opportunity spaces. We provide the opportunity for increasing flight heritage, either through an existing technology or indeed through new technologies. The opportunity that the IOD will give you is to engage with the operators, service providers, and potential customers that may want to use those technologies in the future. And indeed to develop business cases around the use of your technologies. This is something we see very often in terms of new capabilities for flight hardware. Having a really strong case for exploiting the technology in a commercial sense, which is where there's a lot of support for within the UK at least, is often the most challenging element. And we see this particularly in the academic context, and we really identify that as a place where we can help define that much more clearly to provide strong cases for further funding and applications of the technology. Satellite operators, the understanding here is that this will be your asset on orbit. Again, this could be part of a completely vertically integrated organization or indeed as a consortium of interested parties. But the IOD here will help you engage with the technology providers in the supply chain, but also the service providers in the value chain. And that's how we typically split our definition of the people doing the technology and the people providing the commercial opportunities. And IOD will help not only demonstrate that the capability for that exists, but also that you will have the opportunity to have a tangible demonstration of capability to future potential customers. Again, the business case is key here, so helping define that and showing that it's a closed, sustainable and robust case for future investment, whether it's public or private, or indeed engagement with new customers. And also to help test the concept of operation that you're driving. So in practical terms, demonstrating that the capability exists within your organization. So service providers, this is where it gets really interesting. You've got a commercial opportunity, a customer in mind. A lot of stuff can be put down on paper, which is great, but having a real capability is the differentiator here, and this is why the support exists. The opportunity here goes all the way through the value and the supply chain, so helping find providers of the technologies that you need to provide your service. On the other end, helping identify new customers and also working with any existing relationships that you have. Working on that business case again to show that the opportunity closes. And also we have facilities here at the Catapult that allow you to process data and build the service platform. They're cloud-based computing platforms, very similar to the AWS, Google, or Microsoft Azure type services. But keeping that in-house gives you one-to-one, or the opportunity for one-to-one hands-on access to the experts at defining those capabilities, both in terms of the infrastructure itself, in terms of the compute power, but also in terms of the application developers. So that's something that we see as a real differentiator. And finally, the end users. This is something quite interesting. It's in terms of how the new services can help differentiate your capability from your competitors. You can define the capability that you need and work with consortium partners that can build missions to those specifications. And that's where we really see the big opportunity here, and that's why it's really key to see a strong end user or customer element as part of any application. So to bring that all together, the way that we typically would expect to work is an organization as part of a consortium will put in an application as part of the open call that we have for IOD. There's several key elements within that. The first gateway, the first sort of application, which is what we're going to delve into shortly, tries to touch on the main points, which are what your vision and plans are. So we really want to see what the IOD will do for you, how that fits into the longer term plans. There needs to be some specificity around what the IOD mission enables and what the service demonstration aims to deliver, but then that needs to fit in with a wider business plan and business opportunity that also has some robustness to it, so that we can be confident that the mission itself will enable a realistic new commercial opportunity. There is a financial commitment expected, both directly and indirectly. If you need support to financial support to develop any hardware or services or develop a resource capability, that will have to be sourced externally, and we can work with you to help identify that. That's part of our day-to-day activities, in fact. Any hardware that needs to be provided, so the payload, for example, flight models and any engineering models would have to be provided as well into the program, and integration support. So we would expect any applicant to work with ClydeSpace and indeed our own platform, ground platform, the ground segment providers, to ensure that the technology can be utilized appropriately. We'll come back to operations, but from the program side, we provide support with the exploitation of the IP developed. We're not interested in holding on to any IP. We're in a purely facilitating role, but we want to make sure that the capabilities developed by you as our partners are done so to the fullest extent. So we have expertise in-house that can provide assistance with ensuring that that's protected and exploited. By association, the business support is also there in terms of testing and validating your business case. We provide a service called the sprint, or the business plan sprint, where we do a 1 or multiple day intensive drill down into your business case to test it and to validate it. The satellite operations infrastructure, again, sorry, I'll come back to as that ties into operations itself. But briefly, the launch and satellite platform are also provided by the program. That's where the real investment from our side comes in. So what we're looking for from the consortium contribution is a match to that investment. We've spent a significant amount of cash to provide the satellite platform and to provide the launch to orbit. What we're expecting is to see that reciprocated in any application, candidate application, that is. And then in the middle, we've got operations. This is a sort of a logistical consideration. The spacecraft itself remains the property of the catapult, and we will be licensing and ensuring that for operations. Therefore, we will be operating the spacecraft itself within the scope of the IOD program, and we have the ground station infrastructure to do that. But we would expect to collaborate with the applicants into the program to ensure that what we're doing is transferable to your longer term plan for operations later down the line. So we'd also expect to be recoup our costs for that, either through a direct financial contribution from the applicant or indeed through other funding sources that we're always interested in and willing to explore with you. but that is a cost that has to be covered as well as part of the partnership. The journey itself, in terms of how we kick off a program or a delivery of a mission once selected, is pretty fast track. The platforms themselves are standardized bus spacecraft platforms, so we expect that integration and assembly process to be very quick. The duration for development of the payload element, the integration element of the payload, that is also therefore expedited. We have nominally allocated around 3 months for the direct integration activities of the payload with the platform itself. So that's ensuring mechanical and electrical fits are appropriate for the platform, and indeed ensuring that the onboard software development onboard development requirements have been captured and can be delivered in that time as well. So what that means for any applicants is that the technology we expect to see is probably going to be quite high TRL, quite high technology readiness level. That doesn't necessarily mean that we can't work to your own schedules. There is some limit to that. If you've got a 5 or 10 year lead time on delivering a piece of flight hardware, that might be challenging. But if the project were to kick off in 12 months' time and then start this process, that's certainly something that's within the scope of the program itself. But back to the delivery process, once that flight element of the technology is in place, we'd expect to go very quickly. The platform assembly integration is another 6 months, so we would expect to have a complete flight model within 9 months of kicking off the program itself, or the mission itself. There's 3 months where it's delivered to our launch providers, nanoracks. That's ahead of the launch date. That provides time for us to deliver it physically to the integration site, to get it then for nanoracks to integrate with the launch vehicle, for that to be integrated on or delivered to the space station, and then for it to be deployed onto orbit, which is the ISS element on the next line. Once it's been deployed onto orbit, there's a brief LEOP and commissioning phase, and then a nominal 6-month phase as well. The mission operations can be negotiated as part of the contractual element once selected, but that's the baseline that we work to. We provide, or we run a filtering process in terms of the selection. So all of that, I guess these slides are possibly the wrong way around. All of that in the previous slide is what happens after you've been selected, and between now and then there's a number of phases, and that works into, or is defined as, a funneling process, which we've got in this slide here. The first process is discover, and that's what we're doing right now, and that's part of our activities to try and identify opportunities for the IOD program. As you can see, that breaks down into the service, users, operations, and technologies elements. We're interested in people that can provide all of those, or indeed elements of those, so that we can assist with the consortium building. The definition phase is what is really the focus of the workshop in September, and that's where we're trying to help you understand what goes into a good application and what elements need to be covered in depth. So we're going to touch on that shortly as part of this, to sort of manage some expectations around what we would expect to do in September, but also that feeds directly into an application into the first stage of the IOD program. And what comes out from that is, in broad terms, a mission definition. So what you expect to define as part of your mission and the wider business case and commercial opportunity. There is a selection process that immediately succeeds that, in terms of a more comprehensive proposal, filling in any of the gaps that might not have been included in the initial template proposal that we provide, and to act on any top-level feedback that we might have from the initial application. And what that means is that there might be glaring omissions or perhaps misinterpretations of our vision for the program, and this is an opportunity for us to feed that back and to make the applications more robust. Typically that period is around 6 weeks, and that's concluded with a pitching session to an independent board of IOD assessors who will make the final decision on who is selected to go forwards with the application, with the mission itself. This is a competitive process. There are only a limited number of platforms available, and only the best applications will be selected to go forwards with that. That means that if you're not even if you're not successful in the first in a first application, that doesn't necessarily mean you can't reapply, and we can help you improve applications. But there are only a limited number of platforms available, so this is really a critical gate in terms, or the critical gate in terms of getting a flight opportunity. The last two phases are fairly self-explanatory. We've just discussed them. Develop is the element where we will work with you to define a schedule around which any hardware, resource, or service delivery elements will be defined, and then how the flight element of that will be integrated into that process. And then finally, delivery of the service itself. So once we're on orbit, demonstrating the service to the end users. Just to really drill, or to really sort of put the focus back on what it is we want to see, it has to be a clear commercial opportunity. This is what we want to define. It has to be sustainable, it has to be scalable, and it has to be robust. And what that means is, if you've got a great piece of technology that will provide one mission with a new capability, that's fine, but that really isn't within the scope of what we're looking for here. If you've got a technology that could go in onto a platform that then might be used as part of a large constellation and future constellations as well, that possibly becomes more interesting because there's a little bit more sustainability to that program. But we would need to see that directly linked to enabling a commercial service on the ground. The scalability is also a big factor here. We don't want to dwell too much on sort of total market values, although that is important, but it does show that there is a growth opportunity around your service concept. So we need to see both ends of that scale. The specific end users that are going to be addressed as part of this initial phase of your business application, but then also the longer term opportunity as well. Often the longer term opportunity is the easy bit to do. It's £1 billion market that we can get 10% of in the next 10 years. Fantastic. We need to see that, but we really need to see, and in the first 1, 2, or 5 years, here are the specific people that we are going to be targeting and working with. And as I say, having letters of support or any kind of tangible evidence that that's going to be realized is critical to a strong application. We need a mission concept definition. So this is, in a technical sense, needs to explain exactly how you're going to use our platform and what you expect to use it for as part of the demonstration itself. A strong technical case to demonstrate the end-to-end service architecture. And the important part there is the end-to-end bit. The flight segment, or the space segment, the flight element, is only one part of your end-to-end service. How is that going to integrate with your operations? How is that going to integrate with your service delivery and provision? How is that going to integrate with end users and their needs? And how is that going to be enabled by any suppliers in your supply chain? So we need to see a very clear picture of how the IOD fits into that, that overall architecture for the commercial service. Alongside that, the business case, that really leads back into that first point on this slide. We need a viable business model. This isn't about real blue skies thinking. It's not quite on the horizon, and it's not quite sort of market today, but somewhere in between. What's this new opportunity that you can exploit that's realistic in today's terms? And going back to the slide around what we expect from the consortium or the applicant themselves, we need to see a clear commitment that you're going to deliver and invest in this, and that you have a realistic means to do so. And this covers things like the flight hardware. How are you going to cover the cost for development of that? If there is no funding available or identified to cover that at the time of application, while that isn't inherently a problem itself, it does add significant risk to the program itself. The terrestrial services infrastructure, that leads back into that overall architecture. the financial contributions that are necessary, and importantly, we've not really highlighted this yet, but it's a critical element due to the way this program is funded. There must be a UK-based presence for the particularly the service element of this opportunity. And what that really breaks down into is what jobs and revenues are going to be generated that are directly linked to this mission opportunity within the UK. It's UK public money that's funding the program, so it must have an impact that we can measure directly related to the mission itself or the program itself that is based within the UK. So that doesn't preclude international applications, but they must be willing to set up a significant presence within the UK to take advantage of this opportunity and show that there is a return on investment back into the UK economy.
Just to interject one quick question on that we received is do all parties in the application need to be UK based? For instance, if the end users or some partners are based in other countries and they'll have to operate, the service will be divisioned over those other countries. Does that preclude them, or is that acceptable?
So back to the same answer I've just given. We're very flexible and we want to see success in this program, but we must see that return on investment in the UK. If it's manufacturing more parts, for example, that's not necessarily at the question, but it's a harder case to make. What we really want to see are people ideally operating the service from the UK, and new organisations or new business activities that are exploiting that capability within the UK. So certainly that doesn't mean we can't have international partners, but the focus of the benefits have to be UK focused. Okay, so I'm going to delve into some specifics now, and this is really for those of you that would be interested in working with us at the workshop itself. This is an overview of what we would expect to address as part of that program. And to give you just a very quick summary of what we expect to do on the day in September, the morning is set aside to a very broad set of presentations and discussions around what the Catapult does across our business, both upstream and downstream. We have a very small slot to talk about in-orbit demonstration within that, but we've got an opportunity in the afternoon to spend significantly more time either one-on-one or with a group of attendees that would be interested in doing a thought experiment or an exercise around understanding how your specific capabilities might be integrated into an IOD mission. So we see this as a way of us to get better contact with people with realistic and interesting capabilities and ideas. And the benefit and value to you is that we'll have experts on board and present that will help you understand how you might be able to take advantage of sort of the space sector in general, but through the means of the IOD program to exploit your ideas further. So there's two slides in this technical case. I've numbered them just for continuity. But this is the sort of table of contents we would expect to see, and we have some template documents that help guide this. The first element is a service concept. So what is the service that the flight mission is going to provide, and how does that fit into your service architecture? So what is it you're going to provide? How is the satellite service going to work, and what is it going to enable that wasn't there previously? The second element is the end-to-end system architecture. As I said previously, this is actually one of the most important elements. The space segment is a critical enabler, but we need to see how that's going to fit into the entire service or the complete service offering. And really that sort of comes back to where the operator, where the service provider, where the payload provider, and where the end user fit in. And the guidance we give is a fairly comprehensive block diagram is probably sufficient there in terms of how that all fits together and where the space segment fits in with that as an architecture. We will need to see a description of the space segment. So this is specifically how what payload is going to be provided and how that will integrate with the platform itself. some evidence to show that it would be compliant with our platforms, and we can provide interface documents that will help guide that. How the target orbit and launch date will be sufficient for your service concept. So this is an opportunity, in particular, if the low inclination is going to be an issue. That doesn't necessarily preclude you from taking advantage of it, but we have to have some evidence to show that you can still demonstrate some kind of viable capability that could then be extended in future to, for example, a higher inclination operations capability. And finally, also a ConOps, so a concept of operations, how the spacecraft is going to be used on a day-to-day basis to provide this service. Who needs to provide tasking? How is that going to be uploaded to the spacecraft? How often is that going to be uploaded? Does the spacecraft need any ground interaction at all? How the payload will be operated, duty cycling, so on and so forth. And to complement that, also a description of the ground segment as well. So any specific uplink and downlink requirements, how much data you would expect to get down, bearing in mind the constraints of the platform, what the implications are on timeliness, given that we only have at the moment a single operations ground segment based in our Goonhilly facility in the south of England in Cornwall. But in terms of payload operations, particularly if it's a telecoms-based capability, how will that interact with terminals or gateways on the ground? Timeliness as well, revisit rates and the impact of that. If it's part of the IOD mission and it's only going to demonstrate a subset of the full service, that's not necessarily a blocker, but we have to have some understanding of how that's going to fit in. And there's a specific technical point, link budgets for communications capabilities. We can assist with the onboard elements, but again, certainly with the telecoms concepts, what we often get back as feedback from our assessors is a realistic calculation to show what can be delivered in terms of data payloads up and down to the spacecraft. And this can really make or break even an IOD mission, not to mention the future viability for a full commercial service. The user segment is the bit that sort of ends the tale here in terms of how the end users will engage with the service. Are you using terminals? How will they be integrated with the service itself? How will you develop those? How will you test those? What are your test parameters? These are the kinds of questions that we would expect to see. That also links back into, if you pardon the term, the link budget. If you have a very small device for an IoT application in a field somewhere, how will you demonstrate realistically that that can close a link with an on-orbit platform? It's not impossible, but we need to see some evidence that you've given it some thought. The data processing, storage, and dissemination infrastructure, through our operations capability, will provide a pipe of raw data from the platform itself, if that's the operations concept. But once you've got hold of those data, how is that going to integrate into a centralized or distributed infrastructure? How is the end user going to engage with that? And that's the final point as well. So what are the applications? Specifically, how are the data going to be used, turned into useful information, provided through an application, whether that's a smartphone app or a web service or whatever the concept is. We need to understand exactly how that's going to work as well in a technical sense. We also need to see what your system's status is at the point of application. So a Gantt chart or some kind of roadmap over how the hardware and any other technology developments are going to be delivered as part of build-up and throughout the program. The development plan itself, delivery schedule, and importantly, a risk register in a technical sense. Those are all fairly standard programmatic elements, but that's all part of what we would expect to see from the technical application. Now that seems quite comprehensive, but it's to give us a broad overview of what you're expected to deliver in more depth in the later parts of the application process. To give you an idea then of scope or scale, we typically expect this to be no more than 4 or 5 pages in total based on our template. It's somewhat flexible in that respect, but we're not at this stage expecting reams and reams and reams of documentation. That can come in due course. Complementing that, we also have a business case application. This is a similar templated document to the technical case, and this really is the opportunity to describe the wider opportunity. And what we would expect to see is the mission element, the demonstration mission, fitting into that as part of a longer term strategy, and how that would then enable or lead into a subsequent full operational flight, constellation, or whatever it may be that you're using as your mechanism. Frankly, it could even be how that leads into use of existing assets on orbit. Going back to those opportunities that I described in the earlier part of this presentation, if all you want to do is demonstrate that you have a capability and you need easier access to data, or if there's a financial case to show that this is better value for money, that's an interesting concept that's not outside of the scope of what we can deliver. But we need to understand how this mission itself is going to fit into that wider opportunity. So we kick off by giving a definition of the business opportunity itself. What's the gap that you've identified in the market and how you're going to exploit it. Going back to that sort of scalability and sustainability in the next point, number 2, we'd expect to see some initial market analysis. So what your market opportunity is, the addressable size, the scope and scale for disruption, then also how you're going to exploit that specifically as part of the program and as part of your business plan roadmap. What's going to happen in the next 6 months, the next 12 months, in the next 5 years, in the next 10 years. And we expect to see very tangible opportunities that are going to be addressed as part of those early stages of the business plan. The market opportunity that's addressed through the mission itself. Differentiators, that's an expansion of the scope for disruption. So what is it that you're doing that isn't being done currently? How is your approach different? An opportunity specifically here to talk about how the IOD will demonstrate this opportunity. So linking that back to your differentiators and the market opportunity. What is it you're doing differently and how are you addressing new markets as part of that? A value chain analysis. Specifically here, we want to know who is it you're going to be working with, not necessarily as part of the consortium, but the specific parties that need to provide either technology into the flight element, the ground service element, other stakeholders that might be involved, other existing investors, and so on. And so on, or future partners that will enable the full commercial operation of the service beyond IOD. Traction is very important. This leads back into that tangible opportunity. So we need to understand what you've done to date, how you've got to where you are, and where the plan is to go forwards from that. Your route to market, the way in which you're going to deliver your full operational service. Is that going to be through future platforms? Is that going to be through constellations? Is that going to be through partnership with other organizations? And then linking specifically back to how IOD will enable that. The risk and success analysis, risks this time from a commercial sense, linked ideally to a specific delivery plan. The sort of very general stuff is fine, but we want to see that there's been some critical thought given to this. Bear in mind that the funding here is from Innovate, and one of their key sort of comments or directional comments is what they want to support is stuff that wouldn't happen anyway. And what that means in this context is that commercial risk is expected. We want to see organizations taking advantage of opportunities that maybe wouldn't make commercial sense as part of your day-to-day opportunities, but if they can be proven, would open up big new commercial opportunities in the future. So we need to see in some ways that there is some risk to the program or to the application, but also how you're going to address them. Complementary to that are the success criteria, particularly around the mission itself. what is going to be delivered in terms of the mission? How is that going to be measured? What are the quantifiable and qualifiable results that will come from that? And how does that link into your future business opportunity? We will expect to see a summary of relevant skills from your team and from your partners and from across the consortium. Any relevant or specific experience and facilities that can't be delivered through collaboration with Catapult, we would expect to see identified as well. And linking back to what we were talking about earlier, the benefits to the UK. Again, it's UK public money funding this programme. We must see that there is a return on investment in the UK. Just to sort of expand or to reiterate what I mentioned earlier in response to the question, absolutely you can partner with international organisations, but there has to be a tangible return on investment or a tangible impact on the UK economy. And unless that's a specific commercial presence, ideally with some technical element as well, it's not going to make the strongest of applications. So that's the direction that we've been given. Okay, well that's pretty much all I've got to say, and that's a nice round hour, so I'll wrap up quickly. Just to go back over what the next steps are. We're going to be attending on the 14th of September to present IOD to the Centre City community. As I say, that's part of the morning briefing that's going to cover a lot of the Catapult activities. As I understand it, there's going to be the opportunity for one-to-one sessions afterwards, but we see this as a better, wider opportunity to engage with organisations that would like to have more tangible, hands-on engagement, and that's why we're proposing to work with either people one-on-one if there's limited uptake, but if there's a wider uptake, to work with a group as part of a workshop in the afternoon. And what we'll do is follow through those criteria that we have just gone through in terms of technical and business cases, and guide you around developing very nominal mission concepts that might take advantage of ideas or capabilities that your business can provide. And the aims there are to understand the requirements of a good mission concept in general, looking at the opportunity through space, but also specifically through IOD as a program from the Catapult, and to follow the template documents that we use as part of the application process. And that will help you understand either if you're suitable for IOD, if that's something you might want to pursue in the future, and if so, if there are any gaps that you might need to address going forwards. But overall, we see this as an educational exercise and a way to really explore a very interesting new area of potential market opportunity. So please come at it with a very open mind. And with that, I don't know what we're doing for time. Do we have time for a few questions if there are any? Or
yeah, I think if anyone has any questions right now, put them in the panel at the right hand side, and we'll hang around for a few minutes. There's a little bit of a delay, so we'll see if they come through in a minute or two. But otherwise, I think yeah.
Okay, great. I mean, what we'd really like to see is if anybody specifically is interested in meeting with us in the afternoon on the 14th. I think there is a point of contact for the workshop itself. Otherwise, you can email the program directly, which is iod@sa.catapult.org.uk, and we'll include that in the slides when we circulate them. But that's also on the website as well. If you go to the Catapult website, then we have the IOD contact information on there, so you can contact us through that. So we would we would very happily receive any specific expressions of interest to run through that on the afternoon of the 14th. Any other questions?
None have come through that haven't already been answered in some way or other. So I think we'll wrap up there.
Okay. Excellent. Well, thank you very much, everyone, for your time, and hopefully we'll see you on the 14th.